Alright, this afternoon we're going to go ahead and start into Chapter 10. I'm going to lecture for about an hour, and then I'll let you go ahead and start your test. So Chapter 10 deals with exponential and logarithmic functions. So the first thing we're going to talk about is exponential functions, and logarithmics are just inverses of those. Alright, so the first thing we're going to talk about is exponents and exponential functions. So to solve an equation or an exponential equation, you're going to use property 10.2, and this is in section 10.1. On page 533, that's where your properties are. Okay, so basically this property states that if b is greater than 0 and b is not equal to 1, and m are real numbers. So in other words, this is the setup, okay? If you have two exponents that are set equal to each other, two powers that are set equal to each other, as long as the bases are the same, in order to solve this equation, you're going to take your exponents and set them equal to each other. So how is this different from other equations? Well, this time, your exponents or your variables are going to be found in your exponents, okay? And so you know that in order to solve an equation, you've got to get to the variables. Well, the only way that you can get to the variables is to get your bases to be the same. And if the bases are the same, then you're going to take your exponents, set them equal to each other, and just solve the equation like we did in basic algebra, okay? So step number 1. Make both sides of the equation into exponents with like bases, and that's key. You've got to have like bases. Step number 2, simplify the exponents if possible. Sometimes you'll need to do this and sometimes you won't. I'll show you an example of both. Step number 3, set the exponents equal to each other and then solve. Okay? So the key is, again, get your bases equal. Once you have your bases equal, make sure you simplify if needed. And then take your exponents, set them equal to each other, and then solve the basic equation. Okay? So let's look at 4 of these examples. The first one is very, very basic. So just to show you what's going to happen. If you notice, on the left-hand side, we have 3 to the what power equals 81. Most of you know that off the top of your head. 3 to the what power is equal to 81? 4. 3 to the 4th power is 81. Check the math, make sure. 3 to the 4th power is going to be 81. So we already know what x is equal to, right? So how are we going to do this using the property that we need in order to do these other problems? Because these other problems don't look as easy. So this is what you're going to do. Step number 1, make the bases on both sides the same. So I need to turn this 81 into a base 3. 81 into base 3. So you're going to ask yourself exactly what I just said. 3 to the what power gives you 81, and it's the 4th power. 3 to the 4th power. So now that I have both bases the same, all I have to do is take my exponents, set them equal to each other, and you know the answer to the problem. X is equal to 4. Now, like I said, that was a very basic problem, but do you understand the concept? Get your bases on both sides the same. Simplify if needed, and then set your exponents equal to each other and solve. Okay? So let's do this one over here. This one is going to entail some algebra that you may or may not remember. I don't know. I hope you remember. But look, first of all, on the left-hand side, I have a whole number as my base. And on the right-hand side, I have a fraction. So first, what I like to do is I like to get my bases to be the same. So I like to turn this 25 into base 5. How would you do that? 25 as base 5 would be what? Five to the what? To the 2nd power. Do you see what I did? Turn 25 into base 5. So 5 to the what power gives you 25. 5 to the 2nd power. Now what I need to do is I need to get it out of fractional form. So to get it out of fractional form, let's see if you remember this. The left side's not going to change all the way down. It's the way I need it, okay? But on the right-hand side, how do I get that out of fractional form? Do you remember? Basic algebra, Math 100. It's a real easy fix. If you have an exponent in the denominator and you need it to be in the numerator, what do? 5 to the negative 2. Do you remember that? 1 over 5 squared is the same as 5 to the negative 2. Okay? If you have a power in the denominator and you need it in the numerator, you just change it to a negative exponent. It's the reciprocal factor, okay? So now, look, I have my bases that are the same. I have base 5 on both sides, so that's good. So the next step is simplify. There is none. But you're going to take your exponents and set them equal to each other. What's the base going to be all the way across? Yeah. So this first power is good. This power, though, 25 is going to turn into what? Right. And then this one's good, of course. Okay. This time we do have some simplifying to do because, look, we have a power raised to a power, basically is what you're looking at. Power to a power, what do you do with the exponents? Basic algebra. Power to a power. You multiply those exponents, so you're going to have 2x minus 6 is equal to 5 to the first power. Now, what happens when you multiply powers with like bases? What do you do with the exponents? You add them, combine like terms, so we're going to have 3x minus 5. And now, we're ready to set our powers equal to each other. And we have x is equal. So, the problem on the left, on the right, if you have 9 to the x is equal to 27, is there any way we can turn those into the same base?
Divide 27 by 3.
Well, we can turn them into both base 3, right? 9 as base 3 is going to be what? 3 squared, right? You see what I did? Turn 9 in base 3 is just going to be 3 squared. And then 27 as base 3 is going to be what?
3 cubed.
Yeah, 3 to the third power. So we have to simplify again. We have a power to a power. What do you do with the exponents? You multiply. Good. So we're going to have 3 to the 2x is equal to 3 to the third. And now you're ready to take those exponents, set them equal to each other, and you get x is equal to 3 halves. What do you think? Ready to try some? So next thing we're going to do, you need a calculator in order to do this. So if you have a calculator, get it out. Even if it's your phone, I don't care. You still need a calculator. There's calculators up here in this basket, but you definitely need a calculator. And you need to know how to work your calculator for your test 2 weeks from tonight. All right? This test will be 2 weeks from tonight. So you got to have a calculator. If you don't have a calculator, there's some up here in the basket you're more than welcome to. If you have a scientific calculator on your phone, there is an app. It's called RealCalc. It's a scientific calculator that you can download to your phone, but you won't be able to use it on the test. Okay, so we're going to talk about compound interest, and this is a formula, and I will give you the formula on the test, but you have your cards, so you can put the formula on your cards as well if you want to. But compound interest, I don't know if you've ever thought about it or not. I don't know if you've done any investing at all. Probably some of us that are older have done some investing. But when you invest something, especially with this formula, if you go and you invest something and you expect it to compound like this particular formula is compounding exponentially by a certain amount. So when we take a certain principal, let's say we have $300 that we want to invest. kind of a waste of time. But if you have $300 and you want to invest that, A is going to be the amount that you've accumulated after a certain amount of time. Okay, so that's the amount of money that you're going to bring home, minus fees, of course. So A is your total amount of money accumulated. P is the principal. That's that $300 that you initially took to the bank. All right? And then R is going to be the rate. Let's say that you're getting an investment, a CD or whatever, at 5%. So that would be your rate. And I would suggest that you change that to a decimal. It's just easier to work with. So make sure you know how to change your decimal to a percent and percent to decimal. Make sure you can be able to do that. It's just moving the decimal two places. And then N is the number of times that you're compounding per year. And I will ask, please do not confuse N with T. Okay? N is the number of times that you're compounding per year. So in other words, if the formula says, if the bank tells you this is going to compound quarterly, how many times per year would that be? 4. If it says it's going to compound monthly, how many times would that be? 12. Okay. And then T is for how many years. So let's say that you're going to invest $300 at a rate of 5% for 5 years, compounded bi-yearly. Twice a year for how many years? Okay. So that's how you're going to plug this in. Now, if you have my wonderful favorite calculator, this one, you can plug this straight in. Okay, you can plug in your principal, open up a set of parentheses, do everything inside the parentheses, close it up, hit your exponent key, hit your power, hit enter, and it'll do it all for you. But you gotta make sure you plug it in correctly. Because if you don't plug it in correctly, then that could be a big, huge mistake. If not, you have to understand the order of operations, because in the order of operations, it tells us to do parentheses first, so we're going to do what's inside the parentheses and come up with a number. And then it tells us to do our exponent, so we're going to take what's inside the parenthesis and raise it to this exponent. And then the very last thing we're going to do is multiply it times that principal. Okay? And you have to understand also, and this is going to be a little confusing, especially if you come up with the wrong answer. This power has nothing to do with that principal. This power has everything to do with these parentheses, but nothing to do with the principal. Okay? The only thing you want to raise to the power is what's inside this parentheses, this number that you're going to come up with right here. That's order of operations. That's math 100. Okay. So yeah, let's go here. It says find the total amount of money accumulated at the end of the indicated time period for the following investment. We're going to invest $1,000 for 3 years at 5.5% compounded semi-annually. Okay? So my principal is going to be this $1,000. 3 years, is that N or T?
T.
That is going to be T. Good. And your rate, and I suggest that you put it in as a decimal. You're going to move that decimal 2 places, so you're going to get .055. And then semi-annually is going to be your N. What does that equal to? Good. So if we plug in, you're going to have 1,000 times 1. That's just the standard 1 plus your rate, .055, divided by your N, which is 2, raised to the 2 times T, which is 3. And if you want to go ahead and put 6 there, you can. We can do that math in our head. Now, from here, I suggest that you put it all in your calculator and hit equal. But that's up to you, and it's up to your calculator. So what if I don't have a calculator that does that? Well, you've got to come up with a number inside those parentheses. So, if we're going to have 1 plus on this calculator, 0.055 divided by 2 plus 1. So I'm thinking inside here we're going to come up with 1.0275. Can't do that with this calculator. 0.055, right? .055 divided by 2 equals plus 1. 1.0275. Make sure you put .055 in your calculator. And then we're going to raise that to the 6th power, which is a crazy number, 1.176768361. And then you're going to multiply that times 100 by 1,000, which of course is just moving the decimal. So
You end up with 10275 and about 5 zeros on mine.
yeah. And we are talking about money, okay? So we're all adults here, so we all know how money is written, right? Your cents is 2 decimal places to the hundredths place. So make sure you can come up with this number in your calculator. If not, we need to fix that. Make sure you can come up with this number in your calculator. Like I said, on your test, it's just knowing what numbers go where and can you put it in your calculator correctly. That's all there is to this. Okay, it's not rocket science, really. Let's try another one. Okay, so this time we're going to invest $750, so there's your principal. For 6 years, that's your time. And 8.25% as a decimal is going to be 0.0825. Compounding quarterly, that's your N. That's going to be 4. So A is equal to 750 times 1 plus your rate, 0.0825, over N, which is 4, raised to 4 times 6, which of course is going to be 24. And like I said, I personally would put this all in my calculator at one time, but if your calculator won't do it, that's fine. And do 0.0825 divided by 4, and you'll come out with 0.020625 plus 1. So you'll have 1.020625. And you're going to raise this to the 24th power. And then you're going to multiply it times 750. What'd you come up with? 19 cents. Very good. Are we getting it in our calculator? Alright, let me give you one more to work on. Oh, nope. Alright, so this is compounded a certain many times over the year. And again, it's going to grow exponentially as well. So this one, half-life. Half-life is an exponential growth or decay, of course. So for this one, if you don't have much background with half-life, there's a definition here. The half-life of a radioactive substance is the amount of time that it takes for 1/2 of the initial amount of the substance to disappear as a result of decay. That's the definition of half-life. It's the amount of time that takes 1/2 of the initial amount to decay, to go away. Okay? So here's the formula for half-life. You have Q, which is half-life, okay? Q, or amount rather. Q is going to be your amount after the half-life, after we've used the half-life formula. Okay? So Q is your half-life formula, the amount that you're going to get. Q sub O is your initial amount. That's how much you're going to start with. Alright? Times 1/2 raised to T, which is your time, over H, which is your half-life. Every substance on the periodic table has a half-life. Okay, every known live substance has a half-life. So H is that half-life, that known half-life. And T is the amount of time that's in question. Alright? So Q sub O is the initial amount of time, or the initial amount. T is your time, and H is your half-life. Notice that time and half-life must be in the same units. So if your half-life is in minutes, and your time is in years, you have to do a little bit of math there to fix that. Okay? So, this is a two-part question. And it kind of helps you see what's going on with half-life. Because it says a chemical element has a half-life of 30 years. That's just the known half-life for this element. How much of a 75 milligram sample will remain in A, 22 years, and B, 42 years? So let's think about this. In 30 years, half of the 75 milligram sample will be left. That's the definition of half-life. Do you see that? Since 30 years is the half-life, in 30 years, half of this 75 milligram sample will be left. What's half of 75? Put it in your calculator if you need to. What's half of 75? Okay, so in 22 years, should we have more or less? You should have more. And in 42 years, should you have more or less than half? Less. Okay, so you kind of get an understanding of how half-life works? Okay, so let's use that formula. So you're going to have, for part A, Q is equal to Q sub O times 1/2, and it's time over half-life. Time over half-life. So our initial amount is 75. 1/2 is standard. Our time for part A is 22, and the half-life is 30. All right, so let's put this in our calculator. For the 1/2, you can either use 0.5 or the actual fraction of 1/2. That's your choice. So you're going to have 0.5. Now, word of caution. When you put your exponent in your calculator, put it in parentheses. Put your exponent in parentheses. Reason being is if you don't, watch this. You're going to be raising 0.5 or 1/2 to the 22nd power, and then you're going to take that answer and you're going to divide the whole thing by 30. And that's not what I'm asking you to do. I'm asking you to raise 1/2 to the 22 over 30th power. Okay, so be very careful with that. All right, so we're going to have 0.5 raised to, open parentheses, 22 divided by 30, and hit equals, and then times 75. And I'm coming up with 45.11 milligrams. Does that make sense? Because we haven't reached half-life, so we should have more than half left. Okay? So B, let's see if you can figure this one out. Q is equal to Q sub O, which is going to be 75. That's your initial amount, times 1/2. This time T is 42. And your half-life is still 30. That's not going to change for this element anyway. All right, so let's put that in the calculator. We're going to have 0.5 raised to, open parentheses, 42 divided by 30, close parentheses. That's what I got as well. 28.42 milligrams. And that makes sense because that's less than half. And because we've passed half-life, that should totally be it. All right. So again, these formulas, whether I give them to you on the test or not, where do they need to be? On your index card. Put these formulas on your index card. Okay, so now let's play with that E button that some of you were trying to use a minute ago. On your calculator, there is a button that's a little E. Okay? Find it. Make sure you find it. For some of you, it should, well, for all of you, it should be around, you should see an LN button, and your E to the X button should be somewhere around that LN button, because they're inverses of each other. Natural log and E to the X are inverses of each other. Now, what I want you to do is I want you to play around in your calculator and see if you can come up with a number for E to the 0.45. So why do we have a button for E? Well, let me ask you this. Let me ask you a question that you'll know the answer to. Why do we have a button for pi? Why do we have a button for pi? It's irrational, but you know at least the first 3 digits, right? What are they? 3.14, but we all know that it keeps going on forever and ever and ever, and we die before we get the pi in there, right? So our calculator does it for us. E is the same way. E is an irrational number. It's 2.71828, and it just keeps on going, just like pi. So we have the E button, same as we have the pi button. Okay? So now, to put this in your calculator, some calculators are going to be different. For the calculator that I'm using up here, I would hit my Shift LN button, which is going to show me the E in the window. And then from there, all I have to do is hit 0.45. And I come up with 1.568. That's good enough. 1.568. Some of you will have to hit, in your calculator, I think yours in particular, you'll have to hit 0.45 and then hit your E. Some of you may actually have an E button where you don't have to hit the Shift key, which is good. But if your E to the X is above your LN in a different color, that means you have to hit that Shift button before you can get to it. Okay? Is everybody coming up with 1.568? Does anybody need any help? All right, so what did you come up with for the second one?
2.014.
All right, we'll go for that. And then the last one? Good. Very good. All right, so you know how to use your E button, right? Your exponential button. All right, so let's put that into a new formula. This is called the PERT formula for obvious reasons. PERT formula means we're still compounding, but we're compounding continuously. So it takes out the n factor, and we change it to the e, okay? Because it's compounding continuously over and over and over and over and over for the however many times that the amount of time that you're investing. So A is still going to be your accumulation, P is still your principal, R is still your rate, and T is still your time. E, however, takes the place of n this time, okay? Because we're going exponentially. So here we have it. Find the total amount of money accumulated at the end of the indicated time period by compounding continuously, and that is the key here. Compounding continuously lets you know that you are using the E formula. So we have P is your 500. 4 years, that's going to be T. 7% as a decimal is 0.07. So we have A is equal to your principal, 500, times E raised to the rate, which is 0.07, times T, which is 4. So again, this time when you put this in your calculator, depends on your calculator. I'm just going to type in 500, and then I'm going to hit Shift E, 0.07, and I am going to put that in parentheses, 0.07 times 4, close, equals. And I'm coming out with $661.56. What do you think?
What do you do again? 107 times 4.
Just plugging them in. Make sure you know how to plug them in. Okay, so in the next section, we're going to talk about inverse functions. And when we talk about inverse functions, it kind of goes back to Chapter 8 and what we did in Chapter 8. Because remember, in Chapter 8, we learned what a function was. And remember, if I gave you the graph of a function, what test did I tell you you could use to know if the graph of a function was actually a function? The vertical line test. Okay? Well, an inverse function is the mirror image of a function. Okay? So a function has an inverse if you can actually do a mirror image of it. So, remember that a function is a one-to-one relationship between your domain and your range. Okay? So when we talked about in Chapter 8, when we found those domains and range, and I gave you an ordered pair, and for this ordered pair, what would the domain be?
1, 2, 5.
And what would the range be? Okay, so we learned that in Chapter 8. The inverse of that is literally taking those ordered pairs, the x's and the y's, and flip-flopping them. So look, this is the notation for inverse, f to the negative 1, that is your inverse, okay? So when you see that, just know we are talking about inverse. And literally, look at what we did. We took that first ordered pair and we flipped it. Your x became your y and your y became your x, all the way down through. So look at this next section of words here. It says the inverse of any function is a one-to-one relation where the domain, wrap your brain around this, okay, where the domain of the function, the original function, equals to the range. So let's talk about that. What did you say the domain for this one was? 1, 2, 5. What is the range for the inverse?
1, 2, 5.
And that's exactly what that statement just said. Okay? The relation where the domain of the original function equals the range of your inverse, and the range of your original function equals the domain of the inverse. So, for example, tell me the range for your original function. The range, 4, 7, 9, but what is the domain of the inverse? Okay, so do you see what's going on? Alright, so function and inverse functions, when graphed, like I said a while ago, are mirror images of each other. So what we're going to do is we're going to learn how to play around with these inverses and see if we can get a better understanding of them, okay? So the first thing is this. Since we are talking about a flipped function, in order to do a one-to-one function, you're going to use the horizontal line test. And that should make sense because when we're talking about functions, in Chapter 8, we use the vertical line test. Well, now we're talking about the inverses, so you're going to use the horizontal line test. So it's the same concept. If you can draw a horizontal line through a function at any point, and it only touches it once, then your answer is yes. It is a one-to-one inverse function. However, if you can draw a horizontal line and it touches more than once, then your answer is no. It is not a one-to-one. That should be an easy question on your test. Okay? So now, determine whether the function f is one-to-one. Think of the graph. I'm not asking you to do anything except think of the graph and tell me yes or no. This function right here, what is this? It's a straight line. It's a straight line. In particular, if we did graph it, you would come down to -1, and then you'd go down 5 and to the right 1, so it looks like this right here. So is this one-to-one? Yes, absolutely. What about this one? F of x is equal to -x cubed. What does that graph look like? Memorization. It's a up, and away, Superman, however you want to look at it, right? Yes or no? Yeah. X squared plus 4. What kind of graph is that? It is a parabola. It looks like that, kind of, sort of. Yes or no? No. Absolute value. It is a V. Yes or no? Okay. So if I give you a function and I ask you, is it one-to-one? In other words, does it have an inverse? Because that's what you're telling me. You're saying that this one doesn't have an inverse, and this one doesn't have an inverse because you can't do it doesn't pass the horizontal line test. These, however, do have inverses. Okay. So how then do I verify? This is a proof that I'm going to ask you to do, okay? When it says to verify that two functions are inverses of each other, you're going to use definition 10.2, which is on page 550. And basically that definition says this. Don't get caught up in this terminology, okay? If I do f composite g of x, we learned how to do this in chapter 8, so this is a review, okay? If I do f composite g of x, and that is equal to g composite f of x, and both of those are equal to x. So what in the world? If you do f composite g of x, and you do it down and it's equal to x, good, you get a check mark. If you do g composite f of x and you work it down and you get an x, good, check mark. So now they're both equal to x, and therefore they are inverses of each other. The two functions are inverses of each other. So, verify, prove, this is a proof, prove that f of x equals -3x plus 4 and g of x is equal to 4x over 3 are inverses of each other. So I'm stating, my statement is, I'm giving you the fact that these two are inverses. That's a known fact. It's your job to prove it. How? First, do f composite g. You can do either one first. F composite g of x. Do you remember how to do this? That's right. You're going to take your f of x function, and everywhere you see an x, you're going to make a skeleton, right? Look right here. I took my f of x function, and when instead of this x, I made a skeleton. And then what I'm going to do is I'm going to plug this g of x into the skeleton. So we have 4 minus x over 3. From here, you're just going to do some math. You're just going to do some math. So, the 3's will cancel out to -1. So you have -1 times 4, which is -4. -1 times negative x is plus x plus 4. -4 and positive 4 go away, and you get x. Check. But that's only half of it. The other half is g composite f of x. So you're going to do the same thing, except this time we're going to use the g function. And everywhere I see an x, I'm going to make a skeleton. And in that skeleton, what am I going to plug in? Yeah, f of x. Do some math. So we're going to have 4, just distribute that negative, plus 3x minus 4 over 3. 4 and -4 go to 0. 3 divided by 3 is 1, and I'm left with x. And I just proved that they are actually inverses of each other. So what happens if you don't get x? Then they're not. Your answer is they are not inverses of each other. That would be your answer. Okay? Before we go here, and you'll like seeing this because this is very, 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 very simplistic. I'm not going to say easy, but it's follow the steps and you can't go wrong. Okay? So, if I give you a function such as 5x plus 2, if I tell you that you have a function 5x plus 2, and I know that this is a 1-to-1, I know it does have an inverse. Why do I know it has an inverse? If I graphed it, what would it be? It would be a line. So if it's a line, I can do a horizontal line test and it would pass. So I know it's going to have an inverse. Okay? My question to you is, can you find the inverse? And if you follow the steps, the answer would be yes. Watch this. You're going to replace f of x with y. So you have y equals 5x plus 2. And then this is where the inverse comes into play. You're going to swap, just like at the beginning of this section. You remember how we took our ordered pairs and we swapped the x and the y to come up with the inverse? We're going to swap x and y. You see what I did? Step number 3, resolve for y. Use your basic algebra and resolve for y. So we're going to minus 2 from both sides. What is x minus 2? Just x minus 2. And then divide by 5. If I could write, it's going to be a great day. So you're going to get y is equal to x minus 2 over 5. And that's your inverse. So how do we write it? Our inverse function, f of -1 of x, is equal to x minus 2 over 5. So you write it with your inverse notation. Okay? Try the one on the right, see what happens. All right, I'm going to catch up with you and just see how we did. So I'm replacing f of x with y, and then I'm going to flip-flop. And then I'm going to resolve for y. And then, to get rid of a fractional coefficient, do you remember what to do? Multiply by the reciprocal. So we're going to have 3/2 x plus 6 is equal to y. So the inverse of x is going to be 3/2 x plus 6.